The flowing diagram shows how energy flows into and out of a coal-fired power station. So this is the power station of coal power station. So as you can see here, the input energy, the input we have 1000 joules coal. Then 70 joules wasted in friction. As you can see, then from here we have wasted energy, cooling towers. We don't have energy here. Again, we have 30 joules wasted in heating wires. Then the amount of energy here, as you can see, produced is 300 joules, which means some energy was being wasted. So now, for us to find the energy for this component here, which is the cooling tower, so we need to add, which is this 70 joules plus 30 joules, and the produced energy is 300. Then we subtract from 1000 here. Then we find the energy for this part. Because when you add everything, this plus this plus this plus this, we're going to get a 1000 here joules. So now I'll go straight to the question. The question here, question A. So I'll put question A solution here. So question A here. The question is saying that how much useful electrical energy is produced by the power station. So the energy produced here, there's no need for you to calculate. You just need to use common sense. As you can see, the energy produced here is after some energy was being wasted for other substances. So the amount of energy that was produced was 300 joules. So the answer here is 300 joules. That's the answer for A. And for B, for part B, the question is saying, calculate how much energy is wasted from the cooling tower. So this cooling tower. So as I said, for us to find this energy, so we need to add 70 plus this X plus 30 plus 300. Then we subtract from 1000 here. So we'll say 1000 minus. So we need to add. We need to add 70 plus 70 plus 30 joules here, plus again, plus 300 joules, the energy produced there. So we try to add here 1000 minus, so we add here. So we can use the calculator here to add. We have 300 here. The answer to get here is 400. So we subtract here, you get 600 joules. So this amount of energy that is being that's being wasted here on cooling tower. This is the final answer. So I'll go to question C. Question C, I'll write it from here. Question C. Question C is saying, calculate the efficiency of the power station in producing electricity. So they want to find the efficiency. So question C is saying that calculate the efficiency of the power station in producing electricity. So we need to know that efficiency is equal to energy output over energy input times 100%. Okay, so this is the formula for efficiency. So efficiency is equal to, so the energy output here, the energy produced here, as you can see, is 300 here, 300 joules. So put 300 joules here over input energy is 1000. So put 1000 here. Then times 100%. So after calculating on the calculator, so efficiency is equal to, so multiply now. You say 300 I mean, over 1000 times 100%. So get 30%. So the answer is 30% here. So efficiency is equal to 30%, like this. Okay. So the next question is this one. The figure below shows a stone of mass 2 kg, which drops from the top of a cliff and takes 2 seconds to strike the ground. Get acceleration due to gravity of free fall to be 10 meters per second squared. So as you can see of the height here, then of the cliff here, the stone there on top, as you can see. Then here we have this is a stone. The stone was on top there. So it means that since the stone was raised above the ground, which means the stone on top here, the stone had what we call the gravitational potential energy. Then now the first question is saying, question A, name the form of energy possessed by the stone before it falls. So this stone here, it had what we call gravitational potential because the stone was raised above the ground. So the stone had on top here gravitational potential energy. Okay, then I'll go to question B. So B is saying that determine the height h of the cliff. So as you can see, the gravity is given here. So for me to find the height, I use the formula, which is height is equal to, which is same as x, 1 over 2. In fact, I've tried to use that formula, which says x is equal to ut plus 1 over t at squared, like this. Now, since I know that the initial, since maybe the stone started from rest, so it means the initial velocity is 0. So 0 times time here, it will be just what? It will be 0 there. Okay, it will be 0. So 0 times t to be 0. So I'll just give this component here. So which is 8 what? 8 squared. So height is equal to, which is same as x. So height is equal to, so 1 over 2 times acceleration due to gravity, they said is what? It's 10. So I'll get 10 here. Then times the time. The time is given in the question, which is what? For they said for what? They said here it's for 2 seconds. So the time is given 2 seconds here. So I'll put 2. Now since there's 2 square there, so it means 2 times 2. So I'll say height is equal to, so I'll solve here. I'll say 1 over 2 times 10 times 2 squared here. The answer is 20. So the distance, is 20 meters, the height is 20 meters. So our height there is 20 meters. Okay. The question C is saying, question C is saying, calculate the kinetic energy of the stone when it's half down. So it means the kinetic energy halfway here. So here, as you can see, we only have mass, gravity, and height, but we don't have velocity. So and we try to follow the law of conservation of energy, say that energy cannot be destroyed nor created, but it can just be transformed from one place, from one form to another. So for us to find kinetic energy, we need to know that, we need to understand that this question is C1. We need to understand that potential energy is equal to kinetic energy. Now, apart from that, we need to know that since the mass is given in the question there, so we can use the formula for potential energy. So potential energy is equal to mgh. So the mass of the stone is 2, gravity is 10. Now they said that the height, I know the height is 20 here. The height is 20. The height is 20 here, but they said halfway. So it means 20 divided by 2, which is 10. So I multiply now. 2 times 10 times 10, which is 200. 200 what? Joules. So therefore kinetic energy is equal to 200 joules, like this. Okay. Then I'll go to the next part, last part, which is the final velocity of the stone as it strikes the ground. So this question 2C2. So always we need to know that velocity on this topic is equal to, do like this, 2gh. So velocity is equal to like this, 2 times the gravity is 10, and the height, you know, it's 20 here. So just need to substitute in the formula. So velocity is equal to, so you multiply this, you get 400. Okay, so the square root of 400 is what? Is 20 meters per second. This is the answer for this part of this question. Okay, thank you very much. Then I'll go to question number 3. Hope it's very much clear here. So go to part number 3. I'll go to question 3. Question 3, the question is saying, the diagram below shows the path taken by a ball thrown vertically up into the air. So as you can see, so state at which position A, B, C, or D the ball travel fastest. So as you can see, as the ball was moving up here, it was moving against acceleration due to gravity, against gravity. Okay, so so this one is slow, but at D here, the object was moving at a faster rate. Why? Because it was moving toward the gravity. So the answer here is state the position. So the answer is D. The reason is that the reason here is saying that give reason for your answer. So the reason was because at point D the object was moving with the gravity. Yes, with gravity or toward gravity, or gravity was positive. Thank you very much.